GATE 2015 Civil Engineering Set 1 Question number 40. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer. The layer experiences 30 settlement in 2 years. Given time factor 5 by 4 into u by 100 square for u is less than 60% and 1.781 minus 0.933 log base 10 100 minus u for u greater than 60%, where TV is the time factor and u is the degree of consolidation in percentage. If the coefficient of consolidation of layer is 0.003 centimeter square per second, the deposit will experience a total of 50 settlement in next dash years. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data, here we will be using two equations, time factor and degree of consolidation. Time factor is CV into T upon D square, where CV is coefficient of consolidation and T is the time of consolidation and D is the drainage path. As we can see here that D will be H0 by 2 for double drainage path, means as you can see here that the total thickness of the medium is H0, but as we can see here that both the layer are permeable, so here so D will be H0 by 2. So drainage path will be half of the total width of the medium. And for the second figure, we can see here that here it is a clay layer, let's say, but here we are seeing that here is a hard strata. So the water will be draining from only one path. So here the drainage path will be single here, hence D will be H0. Now coming to the second part, which is degree of consolidation. Degree of consolidation is the fraction of ultimate consolidation completed at any time during the consolidation. So we have already seen in the question that if degree of consolidation is less than or equal to 60%, the time factor formula will be pi by 4 percentage u by 100 square. If degree of consolidation is greater than 60%, tau v will be 1.781 minus 0.9332 log base 10 100 minus u percentage. And we know that at 60% consolidation, time factor is 0.283. Now coming to the video solution part, a 20-meter clay layer is sandwiched between silty sand and a gravelly sand layer, and we have to calculate the time for 50 settlement. In the question we are given that for t equal to 2 years we have seen a settlement of 30 and for which we are given the coefficient of consolidation as 0.003 centimeter per square per second, and as we can see that both the layer are permeable, D will be H0 by 2, so it will be 10 meter. So as it is a double drainage, because as it is permeable from both end, so it will be half. So D will be 20 by 2, that will be 10 meter. Now if we use the first formula, which is tau v equal to cv into t upon d square, we can calculate the time factor for 2 years. That will be cv is 0.003 into t is 2 years, so we will convert it into days and then into second. In 1 year there are 365 days, in 2 year it will be 2 into 365 days into in 1 day 24 hours, and then we will convert it into seconds, so that will be 24 into 3600 second. And now we will divide it by d square, so d is, so it will be 10 into 100 square. So now if you calculate it, we will get tau v as 0.1892. But as we know that for 60-degree consolidation we are the tau v is 0.283, and we can clearly say that it is less than 0.283. That shows that the degree of consolidation is less than 60%. So now we will use the first equation. If degree of consolidation less than or equal to 60%, then the formula for time factor is pi by 4 percentage u by 100 square. As we don't know that how much consolidation has occurred, so we will use this formula, and it will be 0.1892 equals to pi by 4 percentage u divided by 100 square. Now if you calculate it, we will be getting percentage u as 49.08%, which is clearly less than 60%. Now we also know degree of consolidation percentage u is also written as delta h upon h into 100%. So delta is the expected settlement or settlement at any time t, and here h is the total settlement. And in the question, delta s is given it as 30 settlement has occurred in 2 years. So we can write 49.08 divided by h into 100. So total settlement will be 30 upon 49.08 into 100. So H will be 61.12 mm. So the total settlement which we will be getting will be 61.12 mm. Now in the question they have asked for 50 mm settlement. Calculate the degree of consolidation. So percentage U will be delta H upon H into 100. So delta H is here is 50 mm and the total settlement is 61.12 into 100. So degree of consolidation coming as 81.81 percentage. So as we can see that percentage U is greater than 60 percentage. So here we will be using the second formula for time factor, which is tau v is equal to 1.781 minus 0.933 log base 10 100 minus percentage u. So now if we use this, we will be getting 1.781 minus 0.933 log base 10 100 minus 81.81. So it will be time factor will be coming it as 0.605. Now as we have to calculate the time, so for this time factor we can calculate the time. So we know that tau v is equal to cv into t upon d square. So we have to calculate the t here. So t will be tau v into d square upon cv. So it will be 0.605 into 10 into 100 square divided by 0.003 centimeter per square per second. So it will be 2.0166 into 10 the power 8 second. Now if we divide it by 365 days into second, which is 86,400 seconds per year, we will be getting the answer in year, which is 6.39 year, or we can write as 6.4 years. But we have to calculate the additional number of years because already 30 mm settlement has been occurred in 2 years. So we can write additional number of year for further settlement, that will be 6.4 minus 2, that will be 4.4 years. So 4.4 will be our answer. So for this question 4.394, or we can round figure it to 4.4, here will be our answer. Reference to the relevant NPTEL courses or video has been cited.